Welcome students. Today I wish to discuss CodeVita contest problem part number 21. I start with the first problem. First problem title is cyclic palindrome. I read the problem statement. Yes, string is said to be palindrome if it reads same from both ends. Given a string S, if you are allowed to perform cyclic shifts, more formally you can pick any one character from any end, head or tail, and you can append that character at the other end. For example, if the string is ABC, then if we do a shift using the character at head position, then the string becomes BCA. Similarly, if you do the same shift using the character at the tail, then the input string becomes CAB. Okay, so you can move, you can take the character from one position and append to the another position, this head or tail position. Okay, and check minimum number of shifts needed to make given string a palindrome. In case we can't convert the string into palindrome, then print -1. For example, first line start T test cases, and then T lines will follow each containing a string S. You have to find the minimum number of cyclic shifts for each string. It can be made a palindrome. Else -1. Number of test cases ranging from 100 and size of a string ranging from 1 and 300. For a given string A, the minimum if you perform cycle lift, that is a cyclic shift. For example, you take B at the last position and add to the head position, means you will get a cyclic string, that is a palindrome, cyclic palindrome. B triple A, then so number of shift needed is 1 here. So you can take any character from head or tail and make a shift to get cyclic palindrome. So this is the implementation. Okay, so we need to check the string whether minimum number of shifts required to make the string palindrome by by making the shift in the left side or right side. Okay, to make the to make the palindrome. Okay, here the input string is read by using the string data type, string object type, which is available in C++. Okay, here I start with the main function. Here I declare the variable t. It's used to get the number of test cases. For every test case, we need to get a string, which is implemented by using while loop. Here string is a object type, it's available in C++. Just declare a variable by using string type and get the input from the user and call the find shift function, which returns the minimum number of shifts required to make a string palindrome. Okay, so I explain the find shift function. Here I define the find shift function which accepts string as here I need to check whether it is minimum number of whether it is possible to make a string palindrome or minimum number of shifts required. Suppose I use a loop. I start from 0 to string length minus string length divided by 2. Okay, no need to check all the string. For example, if I have a character like this, no need to check all the no need to check all these characters to find the minimum number of shifts required to convert the string to palindrome. So I can able to check half of the string. Okay, So just compare first character and last character, and second character is the character which is before last character, like that. Okay, so I start from 0 and shift less than or equal to string length divided by 2 shift plus plus. I just check is palindrome after making this shift whether it is a palindrome or not. Okay, and also I make that is a right shift. For this way I have given minus shift. Okay, if these conditions are either one of the conditions are true means it will return the number of shifts required to convert the string to palindrome. If this condition never works means this statement, there is a program comes to this, the system comes to this and returns -1. It means that it is not possible to convert string into palindrome. Okay, for example, I have s here. S is a string. Shift is number of shifts you made. If you give 0 means the shift made is nothing. Okay, without shifting whether it is a palindrome or not. If it is already palindrome means it will be 0. Shift will be 0. If you give 1 means you have to take one character from the string, first character, and add it to the tail and to check whether it is a palindrome or not. Okay, now if is p of s comma shift means minus shift. Okay, if it is 0 means it means that we have made no shift. If it is 1 means, for example, the string length is 5, consider string length is 5 and you are passing 1 means it means that we are shifting by 4 times. 5 minus 1 equal to 4 and checking whether it is a palindrome or not. Okay, so from this we are selecting the minimum one. Okay, so -1 means 4, -2 means 3. Okay, -3 means 2 shifts. So likewise we are shifting here, don't confuse with minus shift. So if you know the definition of is palindrome means you can able to understand. Okay, I just explain is palindrome. Is palindrome function is a function which is used to check whether the string is palindrome after rotation. It accepts string and the shift number of shifts required. So initially the just get the length of a string. If shift less than 0 means just add it to the length of a string. For example, if I pass the shift value as -1, consider -1 means it -1 will come. Now shift equal to -1 plus 5. As I already told, this is equivalent to 4. Already I told, no, 5 minus 1 4. So 4 shifts we need. Okay, so shift less than 0 means just do shift plus equal to n, that is shift equal to shift plus n. So for shifting to the higher person we are doing this. Okay, now for int person equal to 0, person less than n divided by 2, person plus plus, we're just checking half of the string and checking what is the condition after shifting. Okay, what is the condition of a string after shifting? If position plus shift remainder n not equal to s of n minus position minus 1 plus shift remainder n, what will you get? If it is equal means no problem, you continue with that. If it is not equal means the string is not equal. So if the, for example, if you have so you make a shift here. Okay. You are taking checking last character to the first position, and you are getting B, E, A, B, and we are checking after shifting and comparing first character with the last character. How it is possible? For example, you have made shift one shift, no? So you are starting with 0. Shift is 0. Shift is 1. Okay. One remainder n is 1. Okay. S of 1. After making shift, S of 1 not equal to, just checking, not equal to S of n is 5. 5 minus position is 0 minus 1. Shift is 1% shift. What you will get is of okay. Just checking first person character, last person character. Okay. So here 5 remainder 5. Here I just forgot to mention. We get 0. Get 0. Minus 0 minus 1 plus 1 shift. I just mention position equal to 0 plus shift. Okay. After making the shift, whether it is equal to 0. I'm just checking. After checking, if it is equal means just proceed with the next iteration. If it is not equal means just return true. After completing the iteration only, it will return true. Please understand that. Okay. So in a similar way, it just compare with the other string also. So here it's just check both are same. No? Equal see. After checking S of 1 equal to A only, S of 0 also A. So both are same. No? So you continue with the next iteration. Okay, next iteration position will be incremented. When a position gets incremented means the value will be like this. Here S of 2 will come. Position, if the position is incremented, here S of 1 will just check 2 1 and check 2 1, both are same, no? So it continues. Next iteration, here S of 3 will come. Here S of 2. Just check S of 3 is 0, 1, 2, 3 is B, S of 2 is okay. So it return false. This condition S of 3 is 0, 1, 2, 3 is B, S of 2 is A. So conditions failed, so it returned false. After getting false, just check other possibility. Okay, is P of S comma minus F. It just check other. Okay. So in this way we can solve this problem. Okay. No need to create another string. By using same string itself, we can check whether minimum number of shifts required to convert the string to palindrome. So next question is step over, read the problem statement. In a state of inebriation, a drunkard sets out to walk home afoot. As is common knowledge, a drunkard struggles to find balance and ends up taking random steps. Not surprisingly, these are steps in both forward as well as backward direction. Funnily enough, these are also repeated movements. Now, it so happens that on this trunkard's path, there are two banana skins, one in forward direction and one in backward direction. Okay, we have banana skin in forward direction as well as backward direction. There is a real danger that trunkard's downfall may be accelerated if he accidentally slip over either of those banana skins. The task is to find out if he will slip over the banana skin on forward path or backward banana skin on backward path, and in how much time you have to identify how much time. It is also possible that by his good fortune he might not step over either banana skins. Write a program to calculate the outcome. So here the input format will be in the form of D, FM, BM, T, FBS, BBS. Okay, here first line we have to give a number of test cases. Next line we have to give D. D denotes the direction, either forward or backward, either F or B. Next, FM denotes the magnitude of forward movement in meters. Okay, and BM denotes the magnitude of backward movement in meters. Okay, and T denotes the time to cover 1 meter. So how long they take to cover 1 meter. FBS denotes the distance from trunker starting position and banana skin in forward direction. And BBS denotes the distance from trunker starting position and banana skin in backward direction. FBS denotes the distance from trunker starting position and banana skins in forward direction. And BBS denotes the distance from trunker starting position and banana skin in the forward direction. The output format for each test case, print time taken by the trunkard to slip over the forward or backward banana skin. Okay. Print F if he slip over the forward banana skin, and print B if he slip over the backward banana skin. Both the output must be delimited by white space. Or print hooray if trunkard is lucky to not slip over either banana skin. Okay, so they will give forward directions and VM, FM, VM values, that is magnitude of forward movement and magnitude of backward movement, and distance from trunker starting position to banana skin in the forward direction, and distance from trunker starting position in the banana skin in backward direction. So we need to check whether print time taken by the trunker to slip over the forward or backward banana skin. Constraints n is ranging from 1 to 100, and forward movement greater than 0 and backward movement greater than 0, time greater than 0. Distance to banana skin in forward direction greater than 0, and distance to banana skin in forward direction greater than 0. All values are integers only. Here they are given the directions, FM, PM value, then FPS, PPS value, time also they are given. Okay. I think third one is time. Okay, time means time taken to cover the meter. Okay. Here output will be time taken to slip over the backward direction. Here they are given B means so backward direction. Hurry means he will not slip down. Okay. So first in implementation, just to get number of test cases, and for every test case you need to get direction, which is a character, then FM value, PM value, then time taken to cover the 1 meter, and the FPS value, PPS value. Okay, next just check P equal to F. F means forward direction, and FPS less than or equal to FM. So if the distance to banana skin forward direction less than the FM. FM means forward movement. Okay, magnitude of forward. If it is less than means just time taken to multiply the time taken to cover 1 meter with the FPS, and print the data. Okay, so here also after printing data, you have to mention the direction also. If fps less than fm means just multiply fps with the t. Okay, it's very simple. And if direction is equal to p and pps less than or equal to pm means, so if magnitude there is magnitude of the forward movement or backward movement is greater than the distance to banana skins in backward direction, backward forward direction, just simply multiply the there is a distance from the forward direction backward direction with the time value. Okay, you just check bps less than bm or equal to bm. If it is so, just multiply bps star t. This is the time taken to reach the destination in backward direction. Okay. Okay. If these conditions are not true, for example, fps greater than fm means, or bps greater than fm means, first check fm greater than pm. Okay. So if fm forward movement, that is magnitude of forward movement, is greater than means, we need to keep on add fps with t. Okay, until condition gets true. Okay, if condition is fm greater than fps, that is magnitude of forward direction is greater than fps means, and count greater than or equal to 0 means, okay, just check b equal to f, whether you check, just checking whether you are moving forward or not. If it is forward direction means, just multiply fps star fps with the time. So this is the time taken to uh, move forward direction. Okay. Okay. Then add it to the answer variable. Finally print the answer, then give break. Okay, if it fm greater than or equal to fps, else if fm greater than or equal to fps plus bm means backward movement. Okay, and also you are going to backward means, just multiply bm with t. There is they are going backward moment, no, so just multiply bm star t, bm with t, and find the time both forward moment and backward moment by multiplying the fps plus bm with the t. Okay, finally add it to the answer. Okay, so this is for if condition is true, for example fm greater than bm means. In a similar way, if fm less than bm means, same logic only, but we need to multiply with the bps. Okay, here we do. Okay, here if fm greater than or equal to fps will not true. If fm greater than fps plus bm is not true means, it will come to else part and multiply fm plus bm star t. Okay, so fm means magnitude of forward direction, bm means magnitude of backward direction. If this condition gets false, that is fm less than fps means, you will add fm with bm and multiply by time. Okay, so you have to, for example, if you wish to get a time means, you just find the magnitude of a forward direction and backward direction with the time, and separate with the uh, distance from the banana skin to the person uh, with the fm minus bm. Okay, then increment the count. So if the count reaches certain condition, that is greater than 1000 means, simply that set flag equal to 1, which means that the person will not slip down. Okay, flag equal to 1 means, okay, so keep on checking. If it reaches count 1000 means, just set to flag equal to 1 and come out of the loop. Then in similar way, in else part, you are using while loop, indefinite loop, this one. When it when count reaches 1000 means it come out of this. Okay, if here we are checking same condition, we are in for backward also direction also we have to check. No, there is a you have used a PM greater than or equal to PS, and then count greater than or equal to 0. Okay, this condition is true means check its backward direction. Backward direction just multiply BBS with star with T and store it to the answer. Immediately give break. Similar way, if BM greater than BBS plus FM means, okay, B equal to F means this multiply FM with T and BBS plus FM with T and store into the answer. This is the time taken to slip in forward direction. Both of the conditions are false means just add FM with PM and multiply with T and store to the answer and just upright it. Okay. This is similar to the previous example. If flag equal to 1 means it will not slip over. After a certain threshold, if these conditions not true means the person will not slip down. So if he is not slip down means just print array. Okay. So you are playing with the numbers here. Okay, please understand that. FM means magnitude of forward movement. PM means magnitude of backward movement. T is time taken to that is taken to cross every meter. So ABS is a distance to banana skin in forward direction. BBS is a distance to banana skin in backward direction. Okay. So you have to check here. So ABS less than FM means just multiply ABS time taken distance to banana skin backward direction with the time. Okay. And continue with the next iteration for receiving the next test cases. Similarly, for directions backward means just multiply BBS with T and print the data. So when FM, it is for magnitude forward direction greater than magnitude forward backward direction means you have to keep on checking, okay, whether FM greater than or equal to FS, okay, whether you have reached the banana skin in backward direction. If you reach it means just calculate it. Otherwise, multiply FM plus BM with T and separate with the FM and BM here. That's all. Okay, if no conditions to mean just set flag equal to 1. Flag equal to 1 means it means that the person will not slip down. Okay, so we'll meet in the next class. Thank you.